Hmm. Achoo! Hmm. Hmm.
Hello guys, Ali here again. How are you doing? This is the second of the two videos for my rendition anyway of an Ortho4XP tutorial. What we're going to be focusing on this is obtaining elevation information for airports, creating patch files that we're then going to use in Ortho4XP to give the flattened out runways an elevation profile that better represents the real world airport or airfield or whatever. Now there's a couple of bookmarks that you're going to need. The first one's going to be this one. This link up here is going to be down below this video. Altitude.nu is essentially a map of the world where you can obtain elevation information at almost any point in the world that has it, and the coverage is actually very, very good. So you're going to get yourself this bookmarked, and then you're also going to click on this link, which again is down below the video, for downloading and installing JOSM. Basically, you click on the link or get yourself to this website, click on the installer, download the setup file, install it, and you're done. Please make sure that your Java is up to date when installing this, otherwise you can run into problems when you try to run the application. So with those two resources, you got your JOSM installed and you have this website ready. It's now basically time for us to obtain the runway elevation for, well, the airport elevation, because it's not just the runway I do, it's the runway and the taxiways and the apron that I do as well. We're going to get that information from this map, and that's the first step. The first step is obtaining the elevation information required for the airport. Second one is creating the patch file using that information in JOSM, and then there's the third step, which is building the tile with the patch file, so that when Ortho4XP comes to flatten the runway, it will actually read the elevation information from the patch file and apply it accordingly when building the mesh. Of creating the tiles in general, this process is probably the easiest, but it's the most time consuming because of the amount of, well, I say detail. It depends obviously what kind of standard you have for your profile accuracies. I have quite a high standard. I try to get the best I can out of the tools that I have. You know, like some people just look at runway charts and they look at one end of the runway and look at the other end of the runway, and then they go, okay, well that's 110 feet, that's 100 feet, let's just do end-to-end slope. I want more than that, because you know, runways have characteristics from start to finish that are not represented on a chart, so I want to capture all that stuff, and that's exactly why I do it this way. So we of course created Jersey yesterday, and we saw that Ortho had flattened out the runway completely. So let's get started on trying to rectify that. So we're going to find Jersey again, which is right here. There we go, Jersey Airport. Okay, so we have Jersey Airport. Now when plotting my points, I basically do this. I always plot points at meter markers, and what I mean by meter markers is whenever a full round meter is there. I'm not very good at explaining that, am I? But I'm going to explain it anyway. Basically, we'll start off with the runway, and we'll start off at one end. Okay, so we'll just click there. Okay, so that's 80.72 meters, and we could round it to the closest meter, and that is going to be, so nearest makes no difference, that's 81 meters. Going back here, we can see the slope goes higher. Okay, 82. Does it level off anywhere? Not really. It kind of climbs all the way up to 86. I like to plot. I do like to zone a kind of an introduction to the runway, because then it blends in better, I think, with the rest of the scenery. So I am going to capture. Oh, that's interesting. That really. So we can actually see here. If you look at this, it's Oh wait, I've missed 83. I've missed 83 meters. That could be what's going on here. 83. Right, okay, so 81 meters to 82 is quite a big gap, but then every meter thereafter is reasonably well spaced out. You can assume that that's quite an even slope. it would appear that it kind of levels off here. So what we could do is we could actually go all the way back and just round it off at 86 meters and then do a flat zone that takes us to like that line when we actually come to create the patch file. So that's good. So we have a slope, and then we have a place to level it out so that it meets the rest of the scenery. Then essentially the rest of the mesh can take over, which is great. Cool. So I've got the introduction to the runway there at the meter points, and I can see here that it goes from 81 meters and it slopes down. Does it? Yeah, it does. It's pretty much immediate. Oh, but it slopes back up again. Okay. See, now this is one of those scenarios where you have to kind of make your own assessment. Do you want to represent the gradient? Because there's one thing that you should note, that although JOSM does actually accept decimal numbers as values, Ortho4XP does not work very well with it at all. Every single time I've tried to use a decimal number for an altitude value, I'll also make sure that your units are in meters, by the way, because otherwise, if you put it in feet, like well, for start, JOSM doesn't accept feet as measurements. At least there's been no setting I've ever found that allows for it. So you want to make sure that you're in meters so that you're working with the same unit throughout the entire process. Yeah, so decimal numbers, JOSM doesn't deal with it very well. Sorry, JOSM's fine with it. You can create the file, save it, it's all good. But when you put it into Ortho, it does see the patch file, but it freezes when it's trying to read it. And when I say freezes, I don't mean Ortho freezes, I mean the step 1 process of gathering the vector data just freezes. Because part of the vector data is downloading the information from the OSM off the internet. And as I said yesterday, that's the thing that tells you where all of your lakes are, and your rivers and your coastlines and all that kind of stuff. And then it also looks for patch files that it needs to take into consideration before building the mesh. And then it will find the patch file, assuming you put it in the right place, which I'll show you where to put that later on. And then it will check it to make sure that it's okay. And if it's not okay, one of two things will happen. It will either freeze in the middle of step 1, or there'll be a problem in step 2 when you come to build the mesh. So you cannot sadly use decimal points. Now I personally don't think that's close enough to 80 meters to warrant calling it 80 meters, and it does rise back up again. So what I think I'll do is I'll keep it at the 81 meter mark. So I'm going to make this area here 81 meters. Some compromises have to be made, sadly, but nothing really much I can do about that. Ortho gives you incredibly high detail mesh, but it's just a shame that it flattens out runways. So this is the kind of thing that we need to do to try and counter that. So I've got 80 meters is there. We're going to go with... No, we're not getting down to 79, but I think I can call that low enough to call it 79. Maybe. Well, let's see how the profile goes. It does spike back up again. Yeah, we're gonna come down to 79 there. Again, quite often, I mean, it's really annoying that I've chosen this runway to do a tutorial on, because you don't get these situations very often. But I guess I'm kind of glad it did happen in the tutorial video, so I can tell you how I deal with it, and that's basically just by using my own subjective opinion and going, do I think that warrants going all the way down to the meter? Yes or no? And it's the same on elevations as well. If you come to a part of a runway that isn't quite going high enough to reach the whole meter, do you want to put it up that far? Is it that much of a difference, or is it just would it be best just to flatten it out because there's not much of a deviation worth measuring there? All right, so we actually go up quite steep there. See, this here is quite an even slope until 84 meters, and then it spikes up to 85. It's probably because it's something to do with the taxiway. Let's put this to, we need 86 meters, which is, whoa, again, really quite steep there. It's amazing when you're doing this kind of thing. You'd never, like, until I started doing this, you never really appreciate exactly how erratic a runway can be. So yeah, this goes up to 86.24. What I could do here actually is call that the peak point, because it doesn't, because it looks like it goes to 86.24 and then immediately comes back down. It doesn't plateau. Like there's no plateau on the top. So I will call that the 86 mark. And then it'll swoop back down to 85 again. Try and get the peaks in the right place, because at least then you are capturing the characteristics of the runway. As opposed to having 86, 86 and a flat bit, which doesn't exist in this runway. That would be less accurate. You know what I mean? I hope you do. So what I'm going to do is I'm going to finish plotting all of this out, because otherwise it can take some time. Okay, so that is that's the runway altitude information plotted out. It's not the most interesting runway that I've ever done, I don't think. What I'm going to do here is show you something. You'll remember, obviously, the runway was completely flat in the sim, and we had this weird slope here. Now we can actually get the information that we need to assign that slope the correct values. So what I'm going to do here is plot out like after the runway has finished, so that we can get oh wow, that is insanely steep. Let's zoom in a little bit here. That is really steep. So that we can get that slope accurate in the sim. And wow, that's gonna, wow, that is a steep slope. Let me just mark that in. Well, we've got 73 meters. Okay. 73 meters. 72 meters. It's gonna be, wait, oh, that's not 73. That's, whoa, it does. We'll go as far as the steps, and then we'll let the mesh take over. In fact, we probably won't even go this far, because the mesh will probably take over. It can take over way beforehand. But it was just here. Here was like a really horrible slope, and it wasn't really how it should have been. But we'll get all the information anyway. Plotting this out, like they're all reasonably well spaced apart, so it's going to be quite an even zone. It's not going to be too difficult to do. But still, pain. Such a pain. Good. Okay, cool. So we have the profile for the hill. That's although it's not a straight line, but you know. Now, there's one thing here, which sadly we can't really do much about in JOSM. Obviously, not only does a runway have an elevation profile going in this direction, but it also has one going in this direction as well. As you'll see here, 80 meters in the middle. You know, it kind of goes about half a meter up and down each side. We can obviously capture that in this map, but we can't really plot it in JOSM because of how the zones link together, and I'll explain that later on. When you do gradient zones in JOSM, you need a resolution zone to tell the program the high point and the low point. It's not just enough that you have a gradient zone and then you tell it what the altitude high and altitude low is. You must have a flat resolution point in order for it to be sure. Otherwise, you'll get errors all over the place when you come to build the tile. So that's the runway done, as well as the entrance and exit hills. So what I'm going to do is I'm going to leave you again whilst I do all of the taxiways and the apron, and then I'll explain my thinking behind that as well. Oh, Unity. Great company. Assuming it's the guys who make the Unity engine. I thought they were based in Dem. Ah, well, who cares? Anyway, yeah, I'm going to go and do the taxiways now, and I'll be right back to you. Right, okay guys, that is all the marker points that I require for this airport. I know Jersey's quite a small airport, but just look how many markers I could get out of the map information. I've got enough information here to know roughly where I'm going to make my compromises. For example, the apron. I always tend to flatten out the aprons at an average altitude of all the values there, because quite a lot of the assets that are available for X-Plane, like as far as the buildings and stuff like that for airports, they're not very good at sitting on slopes. Sometimes they stay completely flat, so half of the building is flying and half of it is stuck in the ground. And that looks horrible, so I tend to flatten out anywhere where I'm pretty confident that there's going to be a building that's integral to the airport's appearance. And things like, oops, I did not mean to move that. Things like car parks as well. Cars, car assets seem to be okay with slopes as well, actually, but some of them aren't. So I tend to just, it's very hit and miss, so I just try to eliminate the possibility of it failing. But as far as everything else, I know on the taxiway joining points with the runway, we have slopes going into slopes, which is going to be particularly hard to sort out. Those kind of scenarios are very much trial and error. You try what you think looks good, you render the tile. If it looks balls, you go back and you change it. It's quite likely that that's going to happen throughout this video, and of course I will let you know how I go about changing it. But yeah, that's all the markers that we need for this airport. I tend to go a bit overboard when it comes to the markers sometimes, but at least I have a lot of information to kind of have an educated compromise on certain areas where necessary, instead of just winging it and it looking balls, you know what I mean? So what we'll do now is we need to get this information here into JOSM. Okay, so when you open up JOSM, you're basically fed this screen, bunch of news, pretty boring stuff really. What we need to do to obviously edit the elevation profile of any OSM data for our own local use is we need to download the map that we're wanting to use first. So we hit download. That was the last one I did, but we're going to be going down to Jersey, which is here, and we're wanting Jersey Airport. So there's Jersey Airport right there. So we're going to click and drag a box around there because that is the area that we want to deal with. Hold on, I might make it a little bit smaller actually. Maybe put it to about like there. Oh, and now I'm missing part of the... Oh dear. It's best that you get this right. Make sure you can get all the runway in and as little of everything else as you possibly can. I'm getting myself to the base of the apron, the edge of each side of the runway, and I might as well get those green buildings in as well, seeing as I don't want to just manipulate half of that. So yeah, there we go. So what we do now is we hit download, and it'll contact the server, it'll download stuff, and then we'll be given the OSM map of that area that we selected. But we're not interested in this. Like, this is all the OSM information that we downloaded for the mesh prior to actually doing all this. You know, step one, you click on get vector data. This is all the kind of information that's obtained for the tile. But we don't need this because we're already going to get that. So we're going to create a new layer, and we're going to turn off the old one. No, sorry, create a new layer. Put on a Bing aerial view map so we get a map as reference, and if you can see the lines there of the OSM data. You can see all the taxiway lines and stuff. We're going to turn off that though, because we don't need that, and we'll actually delete it. So we have our data layer 2 up there. This is the one that we're going to edit. Okay, so we have our map as a point of reference, and this is pretty much the map that we're using. This is a Bing map, and that's obviously the map that we're using for our scenery. Yeah, the other two aren't very good. So we're just wanting to zoom in here and essentially get that information there onto this. So we'll start off with the runway. Now the only issue with this is sometimes the maps are slightly out of date, or you know, one map's newer than the other, or it's a different time of the year, so the markings look different, all that kind of stuff. These are both, this is a Google map, this one here, and the other one is a Bing map. So it's likely that they were taken at different times. Apparently both of these were taken in 2016, I think. So it must have just been the time of the year that's different. But we'll make an educated guess anyway. It looks like this bit here is this bit here. So is that right? Let me check. No, it's not. No, it's not right at all. Not at all. Yeah, it levels out there. So 86 at that second line. So one line, two lines. Okay, so it's this bit here. So this is 86. So what we're going to do is we're going to make a zone that is only 86. So there are 3 kinds of zones. 3 kinds? Is that right? No, there are 2 kinds of zones that we're going to be playing with. And we're going to be playing it with a maximum of about 4 variables out of those 2 zones. So what I need is I need to draw a square. I'll draw it this big first and then make it smaller. Now, I draw all of my squares in an anti-clockwise direction. The reason for that is because when zones go up against each other, each side has to be going in a different direction of the flow. So I basically draw all of mine in one direction so that one side of one will counter the one side of the other if they're joined together. So, for example, I've just drawn an anti-clockwise box here for the zone for 86 meters. It doesn't need to be that big though. So I'm going to bring it back. It's just a resolution zone. That's all we need here. So it doesn't need to be very big at all. But it does need to be substantial because this part of the land does actually plateau slightly before it goes back down to 85 meters, which is somewhere over here. So this is a zone, and this small area of the map that we are designating as an altitude of, was it 86 meters? It was 86 meters. Okay, cool. So 86 meters. Done. Altitude 86. That's now a flat piece of land at 86 meters. The mesh and everything else to do with the tile that's done automatically will govern the rest of this right now. But this here is definitely 86 meters because we've told it is going to be 86 meters. Now, if we're going to add a zone onto this so that we don't have breaks in our gradients and stuff, we need to make sure that they're all being drawn in the same direction. Now, you'll look here. Anti-clockwise, so this side here is flowing in this direction. When we draw an anti-clockwise box again next to it, the joining side of the box is going in the opposite direction. See what I mean? So this box here, the intersecting side, which is in this case the right hand side, is flowing in this direction, and this box here is flowing in that direction. You want that to happen, otherwise you'll run into issues where you'll get errors in step 2 of ortho because stuff just isn't making sense. And you'll also, when you do validation, you might get some problems as well. The validation tool is actually quite handy. I don't use it very much. The only thing I ever get is warnings because nodes are overlapping, but that's normal. So yeah, so we've got our 86 resolution point here. Actually, the 86 part goes all the way back to about there. So I actually made it too small. I'm trying to find a marker to align that with in my head. Okay. So we've got this road about there. Okay, cool. Let's make that bigger. The plateau goes on for longer than I thought. How about that? So this entire area is 86 meters, okay? And then we have a gradient. And the gradient is reasonably gradual and even as well, all the way to 82 meters, which is at this first marker here. So it's 86 to 82 over that range. Because they're quite evenly spaced out, we can assume that it's quite a level gradient, that there's not any parts that are steeper than others because of where the meter markers are. So we're going to now, okay, so before I do this, I should make one thing clear. When it comes to altitudes, like flat areas, it doesn't really matter how many nodes you use. I mean, you could have a flat area that looks like this, right? Watch. You could have a flat area that looks like that. In fact, when we come to do our apron, it's going to look something like, it's going to be an odd shape. All this area here within these lines is 86 meters. You can have as many nodes as you like to create the shape. However, when it comes to gradients, you're only allowed to use 4 nodes, and your first 2 nodes are the most important. These are the ones that tell ortho which side of the square, because it's got 4 nodes, which side of the square is the highest point and which side is the lowest point. So essentially what you're going to do is you're going to go, so your first 2 are high point to low point, because obviously we're starting at 86, we're going to 82, right? That's high point and low point. And then the next two are just basically finishing off the area that it's affecting, which is essentially that. Okay, now that's not quite straight because I screwed up, but you know what I mean, right? So it's most important, gradient zones have a maximum of, sorry, it's not even a maximum, they have to have 4 nodes. And the first 2 nodes that you plot govern the direction of the slope from high to low, and never from low to high. So let's say, for example, it was 86 on this side and 82 on this side, and I drew the square how I did just now, the slope would be going in the wrong direction. So high point to low point every single time. For example, in this area here, we're going to draw it in just for the sake of demonstration. This way here is 86 to 85, right? So high point starting from here to there. 86 to 85, first 2 points done. The rest of the zone governs how much of the, what area of the map is being affected by the slope. And if I were then to do 85 to 86, now bear in mind as well, I am always drawing in anti-clockwise directions to make sure that the zones link up properly. And if I were to do an 85 to 86 zone, I mean that's not what this is, but if I were to do it, like do a zone in the other direction, in fact, I'll just delete the zone I just made and say it was 86 to 88, right? I would have to start from the high point, remember? So the first point of a zone is a high point. So I'd actually have to start away over here, 88 to 86, and then finish off the block. So always keep in mind what direction your slope is going in, which side is the high point, and make sure that your first point always represents where your high point is going to be. So I hope that makes that clear. So we've just done a zone that's going to represent 86 meters going all the way down to 82 meters. Okay, so we need to put the values in for this. Now with this, it's actually very important that you have the entire zone selected, because in JOSM you can just select nodes on the corners. You know, you can do that. The only problem is if you put the values in that, Ortho won't read it. So you need to make sure that the variables apply to the entire zone. And what we're going to do is we're going to use a variable called altitude high, and obviously our high point is coming from 86 meters. Okay. Our altitude low, which was our second point that we plotted, is 82 meters, because that's where we're going to be going to. As you can see here, 86, 82. And then I use a variable called cell size. Now, I'm not entirely sure what cell size is, but what it does is it solves a huge number of problems that I used to have when I started doing this. And I'm not entirely sure why it solves the problems, but in every single slope I do ever since I discovered this tool existed, I've always put the cell size, and I've never had a single problem with a gradient zone ever. So I'm going to put a cell size of 2. That's what I put in them all. Done. So what this piece of land, what this part of the mesh is going to look like now, is it's going to come from 86 meters and it's going to slope to 82. But that's not all. Remember how I said you had to have a resolution zone for gradients. Now for this side, the high point, we have a resolution, 86 meters. For here though, we need one that says 82 meters. So we have to look at here and go, right, okay, so 82 meters is here. What happens after that? Oh, it's still sloping down. Fine. So we're not actually trying to flatten out this part of the map at 82 meters, but we have to, even just a small, tiny bit, just to tell JOSM that, by the way, the gradient ends here at this value, at this fixed altitude, which is what this kind of zone is, and it's going to be 82 meters. Now, on the mesh, this is going to be almost invisible. It's going to look like the slope, maybe the gradient angle has changed slightly, but it's not. You're not going to see any like straight line, like flat evidence of it being there. So this tiny zone, our resolution zone, is 82 meters. Done. So we have 86 meters. It's a big zone because it is a big area of 86 meters. We can see that there. And then we have our gradient that goes from 86 to 82. 86 to 82, which is here. 86 high, altitude low, 82, cell size 2. Remembering high point, your first point that you plot is your high altitude. The second point that you plot is your low altitude, and then the rest of it is just, you know, covering the amount of space that you're actually applying the gradient to. And then we have this tiny, tiny little zone, 82, to tell this gradient, by the way, that's where you stop, and it's a definitive 82 meter resolution for that gradient. However, in the real world, we are still going down, and 81 meters is here, and we need to obviously do that slope. So we're gonna draw that slope in just now. That's about here, right? We'll say that's about there. So we go from our resolution here, our resolution zone. Now the slope is going in this direction, from high to low, isn't it? So 82 to 81. So we need to make sure that we're still doing anti-clockwise, and making sure that we're plotting the high point first, which is what we've done, and now we're plotting the low point, done, and then we're just continuing to fill in the rest of the zone that's going to be affected by this slope. Okay, so we do the same again here. Now remember, high point first. Obviously we did first, so we can be sure that altitude high is going to be, click please, 82 meters. And altitude low is going to be 81 meters. Done. Cell size of 2. Now, we need now obviously we drew this gradient zone from a flat altitude area, a resolution zone. So we've already resolved the high point of this. We've already resolved the 82 meters part, because that's flat. Just like the resolution for the high point of this one was this flat area as well. So what we need to do is we need to resolve the 81 meter part. So whenever you do a gradient that needs to change angle, you know, change its extremity, like from here, a gradient from meter to meter was quite balanced, so we just did that all in one big zone. But the meter drop from here to here is a lot more lenient, so we had to change the rate at which it actually descended. And that's why this zone covers less of a descent, but over a bigger area. So we can represent the change of that gradient. But we still need to resolve it. And we need to tell JOSM that this tiny, tiny area here... Actually, no. Not tiny, tiny, because 81 meters is all the way up to here, isn't it? So we're going to draw a bigger resolution to represent that flat area. So let's do that. This is 81 meters. Now, one of the compromises I'm going to do in this taxiway is flatten out this area. Now, obviously, this is a flat zone, so we can use as many nodes as we like. You couldn't do this with a gradient because you have too many nodes, it does nothing. There we go. And we're going to put that as an altitude of 81. So that does two things. That tells this entire area that it is 81 meters in elevation. And it also resolves this gradient, telling JOSM that this gradient here comes from an altitude of 82, and it's confirmed like the slope begins at 82 meters in this zone, and then it finishes, the altitude low of this zone is 81, and it's resolved by that. Although obviously this is a much bigger area because of the flat 81 meter part of that runway. So I hope you guys are following me. I know it's quite a lot to take in, and quite a lot of this may be trial and error. A lot of this stuff, I mean, there was a couple of guides on YouTube. I didn't understand at all what was going on, so I just played around, and that's essentially how I know what I do. So quite a lot of it will just be playing around, but hopefully this information will get you off to a good start. So that's it. I mean, they are basically the only things you need to know. How to do a fixed altitude of, you know, whatever the value is. How to do a gradient, high point first, leading to the low point in the direction that the slope is going in. There is no exception to that. And then, of course, the other 2 points to designate where that gradient is taking effect on the map. Your resolution point, which is just another flat point to tell JOSM to confirm the finishing slope altitude. And then making sure that when you do assign variables like altitude, altitude high, altitude low, and cell size, that you are applying it to the entire zone. So you click on the zone. So you click on the zone, make sure the entire line is red. If you just click on a node and then you apply all the stuff, when you come to build the mesh in step 2, you're going to get an error, and it will not work for you until you correct it. I've done it so many times just by misclicking on things. The first thing I do when I do get an error on step 2 is look at my my zones and look for any blue dots, and I'll show you what I mean. So if I were to put an altitude value here of 81, see how that's blue? If I see any of these, I go, crap, I've put that in the wrong place. Like I've accidentally clicked on the node instead of the zone. So then I take it off, I click on that and I hit delete, and then I take it, I write it back into the zone, and everything is all well. My tile gets built, and then I see if I've done a good job. So what I'm going to do is I'm going to continue moving on until we come across another issue which I think might be worth mentioning to you to keep a lookout for. Oh, one more thing before I do continue on. I just realized I didn't tell you guys how to save it. There's a particular thing that's a good practice to get into to save these, and make sure that the Ortho4XP application can read the patch properly. Now, basically, first of all, it's a really good idea to make sure you save regularly. Like whenever you do anything, Control S, anything at all. Obviously, if you've saved it already, that won't pop up. But we're going to go to Save As just now. Now, the important thing about saving things, in your Ortho folder, you'll have a folder that says Patches, and there'll be some ones that are already there because of the demonstration exercises that are in the manual for the program. However, if you're making your own, you'll need to make sure that you make your own folder for the tile that you're making. Now, we're making, it's +49 -003. So what will happen is when we come to create the patch, when we come to create the tile through Ortho, it's this folder that Ortho will look in when looking for patch files. So you go into that folder and you can name the patch file whatever you like, but there's a particular format to how you type it. Now I tend to go for the iCal codes for the airport. So this is egjj.patch.osm. Whoopsie, .osm. There. It needs to be done with the patch.osm, otherwise it will not work in Ortho. I used to do egjj or whatever, egph, which is when I first started doing it, .osm, and Ortho wouldn't find it at all. It was in the right folder and everything, but it just would not find it. So egjj.patch.osm. Save. And then you're done. So now, obviously, whenever you make any change whatsoever and you're happy with it, just hit Control S every single time. Make sure you save like an absolute trooper, because if you don't save and you have a power cut or whatever, this, as I said, this is quite a time-consuming process, and you will rage, or at least I rage, whenever something like that happens. Like if JOSM decides to crash. That's happened to me a couple of times. On a couple of those occasions, though, it has resurrected like a cached version of the file, which is nice. But sometimes it doesn't successfully do that, and I've lost like 2 hours of work. Pain in the ass. A really good practice to get into, in fact, is to test your tile regularly. Once you've done a little bit of the runway, or maybe you've done the entire runway, instead of jumping right onto the taxiways and the apron and stuff, it's good to just test what you've done and make sure that it's working. Otherwise, if you do an entire airport and then you try and put the patch file into the mesh and there's a problem, you'll have a much harder time trying to figure out where, like, what you've done that's caused that problem. Whereas if you do it every now and again, you can remember what zone you've just done since the last time you tried the patch, so you know roughly where the problem is, so you can go and check a smaller area of data. So we're gonna just build the patch just now. Gonna get the vector data in. There's 3 airports in this tile. I thought there was only 2. I need to find out where the hell that one is. I'm going to set up. You can set up while step 1's happening. You can set up stage 2. You just can't press the button. Well, you can, but it'll tell you no, 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 and then no means no. So we're getting all the information much quicker today as well. Much quicker today. I remember one time, like the thing that taught me to actually test my patch files more regularly was the first airport I did was Edinburgh, and I did Edinburgh, and I did the entire thing. It was all zoned out. It was great. I was so proud of myself. So I opened up this. I was like, oh, great. I can't wait to see. Oh, great. It found the patch file. Fantastic. Okay. Build mesh. Errors. No! So I did the entire airport, and there's a problem in there somewhere, or maybe in more than one place, and I couldn't figure it out. I did find a couple of problems. I kept trying to run the mesh, and it just didn't work because something else was wrong and I wasn't seeing it. So I ended up starting again completely and testing it after I did each runway, after I did each taxiway, after I did the apron, all that stuff. Make sure you test your patches properly. So, step 1 has been done. We've got all the information for the tile. It has found the patch because we saved it properly. See how it says it there? Adding patch data for mesh, and it's found our patch. And now, obviously, step 2, as you know, curve tolerance, I set mine to 0.5. Check minute angle. I always leave it at default of 5, and then make sure that you've got your height file in there. Press this. And this is good news. That means, usually if there was a problem, it would tell you that there was a problem calculating triangles or something, and it would give you an email address. You don't want that. Also, the email address doesn't work. I've sent emails, I never get replies. So, you want to make sure that you don't have to even see that message to begin with. Now you see that already. Remember it was like 131,000 triangles when we did this yesterday. When we did this in the last video. Now it's 153,000. So the small amount of work that I've done on the tile so far, that's a good number of triangles in there. So that should be a good detail elevation. It should look really, really nice. But yeah, you get to stage 2, you build that, and as long as this goes through fine, you know you've done okay. So now you can close this, get rid of the folder that's just been created, because we don't need it, because we're going to test more. We don't want to have existing data there. Minimize that window so you know where it is later. And actually no, don't minimize that window. You can actually open up the patch from your patch folder. That's it, yeah. That's our patch. And it will automatically load up that session for you. All you need to do is put your map back on and you're sorted. So yeah, a couple of helpful tips there. I'm going to get on with this runway. I'll let you know when I've done. Okay guys, that is the runway done. I've just run it through Ortho to make sure that it still works and the patch file is fine. No real problems at all. For the most part, it's exactly the way I plotted it out on the map that we were using before, this one here. I took a little bit of a compromise here, flattened this bar out to 79 meters, and then the rest of the mesh that's already in the sim will take the slope down by itself. Other than that, nothing particularly wrong. As you can see, well, that's actually a resolution area itself. It's quite a big flat area, but between all the gradients I have my little resolution areas that are nice and small and almost invisible. Trying to find another one, and that is a resolution zone of itself, so is that. Things like that, they're almost not there, and when we get them into the sim you'll see what I'm talking about. So what I'm going to do now is I'm going to move on to the taxiways and attempt not to screw things up. I will come in at both sides and I'll get the apron done as well. And then I'll let you see it again. And then after that, we're ready to put it into the sim. So I'll get on with the taxiways. I've been doing this now for, I'd say, about an hour and a half, about 90 minutes to get all of that done. Maybe a little bit less, something like that. But I'd say I've got another, at least another hour to do to get everything else done and correct. So I'll be right back to you when that is done. Okay, dokie. Right, that's all of the grid done. As you can see, I've done the big apron zone and the pits adjoining to it to the same altitude because that's just convenient. It was how it came out in the actual. You know, you got 81 meters leading all the way there, and I was going to average this out at 81 meters, and then there was an 81 meter entrance here. Kind of convenient. At least I thought that this airport would be a little bit more of an issue than it is, but putting it together wasn't actually too hard. So a couple of things to note. There's this bit here. Now we have a fixed altitude leading into a gradient of 81 to 84. It's very hard to blend these. It is very, well, from my experience anyway, I found it to be very much guesswork. You just got to try and to imagine, like obviously it's higher here than it is here. So you want the, you want the altitude to be closer to this area than you do this area. I'm basically leaving this area clear just to see what happens, because sometimes it works out okay, sometimes it looks very bumpy and weird. We'll find out what happens and then we'll tidy it up if necessary through just repairing this file. Yeah, I think that's everything I need to say. Obviously, you got the little resolution zones between every gradient, keep it all nice and tidy. The run into the runway, all the little, like whatever assets are going to be, are flattened out to a reasonable altitude based on the average for the area. Average for this area, well, there was an area here that was 77. So I basically just put that entire. Oh no, wait, hold on. Where am I? I think I'm looking at the wrong bit. Yeah, this bit here. Sorry. Yeah, this bit here I just put to around 77, and this one I actually did as 79. Not 78. Sorry, 78. Which hooked onto this area that was also 78. So yeah, a little bit of compromise there to make it a little bit easier for placing assets, and so that half of them aren't flying in the air. But for the most part, that's exactly how I mapped it out on the map initially. So let's go and put it into Ortho. Okay, here we are with Ortho open. We're going to obviously do the same tile as we did before. We already have the Ortho photos downloaded because they're actually saved on your system, unless you delete them, in this folder here. If you go to Ortho Photos, you choose the relevant grid. Everything that you downloaded to create your tiles is saved here. So as long as you don't delete these and you make a tile with the same zoom resolution every time, you don't have to re-download anything, which of course saves time when it actually comes to building the tile itself. So we're going to set ourselves up here. Zoom level 18, ratio water, I like to do 0.7. We're going to purge the OSN data and then build the vector data in step 1. Hopefully this won't take as long as it did before. And it looks like it might. Oh no, maybe not. Okay, so what's happened here is there's a problem with the patch file now that I've finished it. So we're going to have to go back in and find out what the problem actually was. Hopefully that will not take too long. Let's close this. Open up the Ortho folder because I closed it by accident. Game files. Let's see what we got here. This is the tile we're working on. There we go. I wonder what I could have done wrong. Let's have a little look. First thing I like to do is to scan for blue dots and make sure that all of my zones have the appropriate separation. Okay, cool, that's fine. Looking through all of this, it was fine until I started to do the taxiways. That was the last time I tested it, was when I did the taxiways. So I need to find out what's gone wrong. So that means that this should be 76. And it is, and that's 7 through to 78, and that's a big zone there, so that resolves that. 80 to 81, and then that resolves that. That's fine. Let's see what I may have done wrong here then. So I know these are right because we did these last time we checked, so I'm going to make sure that this is okay. 77 to 78, 78 is there, 78 to 79, 79 is there. 79 to 80, oh yeah, it's quite a long stretch. And 80 is there, 80 to 81, 81 is there. Okay. Um, 80 to 81, which means this should be 80, and it is. This entire area is 81. 81 to 79. 79 is there. 79 to 77. 77 is here. Oops. 77 to, so that's 77 there. 77 to 82. Okay. That's fine. I'm expecting to find something really stupid. I really am. 77 to 75. 75 should be here. It is. We've got here, we've got 76. Cool. 78 leads to that. 78 to 80 leads to this. Same with there. 81 to 80. There's 81. Okay. Struggling. What could be the problem here? Altitude of 80. 77. 78. Oh, it's this. Oh my god. I put the altitude on a node. See what I mean? Little things like that. That's what I did wrong. Delete that. Put the altitude of 72 on the entire zone. Okay, that should work now. Let's check. Go back to Ortho. We'll have to start the process. I don't know if it will. We'll have to exit. There we go. Delete the folder that was created. Start again. 49003. Zoom level 18. 0.7 on the ratio, and get that vector data. Oh, whoops. Sorry, build vector data. I hit purge, but didn't hit the other one. So fingers crossed this is going to be okay. And there we go. We have the patch file detected, and it's all the process continued afterwards. So it looks like that node issue solved the problem. Let's get the stage 2. This is the moment of truth. Stage 2. Fingers crossed that all goes okay. Got the height map there. An angle of 5. Let's go. Oh yes! It's all good. You really don't want that email address popping up. It's like such a pain in the backside. But everything seems to be okay. Number of triangles calculated. All done within 6 seconds. Fantastic. So we'll do we'll build an overlay. And I'll tie it back into where I have put my HD version 3 mesh, which is here. And we'll get it to build the overlay. We're going to build the masks of 4 again, because that's what I like to keep it consistent to. There we go. Building up that damn tile. This should take a few more seconds than the other 2 steps. So yeah, with the patch, as I said, all it really does is take Ortho's wanting to flatten things and give it something else to do instead. At least that's how I think about it anyway. Because as you can see here, where is it? Yeah, here we go. So in stage 2, when the mesh is being built, it flattens the airports, and then it does the patches and smooths them out. So it flattens the airports, and then the patch files are processed to be incorporated into the mesh, and then obviously our patch file is covering the area of the airport, and that kind of solves the problem with the flat airfields. So that's everything done. We've got our vector data, the base mesh is done, we've got our overlay, and we've built the masks. Now we just need to build the tile. Again, you'll see that it'll be a little bit different now. Instead of it saying downloading missing photo, it will say the ortho photo blah 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 is already present. And that's because in the last video I already downloaded all of these, remember, when we built the tile. So I'm quite curious actually to see how this is going to look. I don't think the runway or anything is going to be a problem. I'm more concerned about that taxiway leading into the runway, to see if it's going to look weird at all. If it is, we can just come back and fix it. But fingers crossed, it actually looks okay. And some of these times, when you're doing these files, the less you do, the better in some cases, rather than overthinking it and making it too complex. Because if you make it too complex, you just start trying to fill areas with altitude and altitude values and elevation profiles and stuff, you can sometimes make it look really weird. And I've done that so many times. So fingers crossed it all goes okay. So I'll catch you when this tile has finished rendering. And there we go, that's the tile built. It took 360 seconds. That's 6 minutes, I think. That's 6 minutes, isn't it? Yeah, 6 minutes. That's not too bad. Certainly shorter than the amount of time it took before when we were downloading all the photos. It's amazing how much time you save just having the photos in your system. Anyway, now what we need to do is do what we did before, which is take both of these files. Actually, we'll close Ortho first. Exit. There we go. We'll take both these files. I'm going to cut them, fire them over to my X-Plane folder. Boop. Custom scenery, and just whack them in there. Yep. One thing I probably should have done was deleted the old one, but I'm sure it'll be okay. Yeah, I'm sure it'll be just fine. If it's a problem, we'll just redo the tile. Anyway, so let's get ourselves into X-Plane and get it all loaded up and see what it looks like. EGJJ, Jersey, and the Airfoil Labs, boosh. There we go. Tum-ti-tum-tum-tum. Right, so here we are once again. I haven't sorted out the stationary objects yet, but there we go. And the profile has taken nicely. Now my concern was this. Let's see it. Did it sort out the gradient itself? And it did. I was so hoping that would happen. I was worrying that it wouldn't solve the gradient by itself. It would just look all weird, but no, it looks good. Let's check the runway, make sure I've not got any steps. Sometimes you can get steps if you've maybe put the high and the low in the wrong order. But yeah, so our slope starts from way up here. And oh, that's weird. Oh yeah, the lights are they're on stands, aren't they? I can never get used to that. I never get used to that. So weird. Anyway. Right, so are they not supposed to be rolling in the other direction though? It seems like they're backwards. No? I just noticed that. I should have noticed that yesterday, but I just noticed that now. Seems like they're running in the other, like they should be going high to low rather than low to high. Anyway, I'll probably be able to swap that out myself in this like overlay editor or something. But anyway, let's just check this, make sure it's running reasonably smooth. Yeah, it's a weird runway. It's not like a particularly crazy runway. It's just sometimes a bit weird. Yeah, so basically what I'm looking for is I'm looking for steps, like random little parts that look completely wrong. And then there's the slope. And it worked out the slope lovely. Good stuff. It worked out the slope really well. I'm quite happy about that. I didn't think it would work out the slope that well, but it did. Good. Good. And then of course there are taxiways. Make sure that they're alright. You can always tell when there's problems because like the straight lines start to go a bit squiggly. Through getting kind of like confused by the mesh. Yeah, that worked really well. That worked really good. I'm quite happy with that. Slight downhill slope here into the nicely flattened 81 meter elevation apron, which I flattened out, because it does kind of go from 81 to like 82.5 in areas, but I decided to make it all 81 so that the buildings can sit well on it, and they do. And they do. Those other areas that I did as well. Yeah, this area here sits well. Just wish there was more buildings, you know? I just wish there was no more buildings. Okay, going along the floor again. For some reason, I don't know what that theme is. What is that theme? Whatever it is. It's a theme from something. I don't really know what it is, but it's in my head today. It really is. Cool. It's a shame. I might go into Photoshop at some point and get rid of these because it's weird having planes textures on the ground. It's kind of weird. Cool. I think it all looks good. What I might do in my spare time is move the runway slightly, because it's slightly, ever so slightly out of alignment. But other than that, I think it's looking very good. Very, very good indeed. But the purpose of this tutorial is obviously the creation of the tile and the runway profile, and that is something that has been nailed. This isn't like obviously the first airport I've done. I've done a few, starting from the north. Actually, I started with Edinburgh and Glasgow and Prestwick and Cumbernauld, like that area of Scotland, because I know it, and especially Edinburgh, I kind of know what it looks like from there, and I decided to do those as I have a good sort of memory reference of what it's supposed to look like, and they turned out really well. I made a ton of mistakes in Edinburgh. Edinburgh was my first one, but I made loads of mistakes there. And now I've got the process, with the exception of the occasional derp, a lot more refined compared to how it used to be for me. So, as you do this more and more, the process, with the exception of obviously making the tile, like building the tile, it gets quicker and quicker and quicker, and you make less mistakes. It is a time-consuming process, though. It never happens like that, but it is something that once you refine your method a little bit, you will manage to do a lot more in a shorter amount of time. But yes, as I said, I might go into WED later and move the runway ever so slightly, because it's just slightly out of alignment. It's not as bad as some of the ones that I've seen. Not by a long shot, but I still might just nudge it somewhere. I might do a tutorial on WED sometime, and perhaps put that onto YouTube so you guys know how to use that too, because I mean, Cumbernauld was the first airfield that I had to do it with. The runway was way away from where it is on the photo scenery. It's so far away. It was a good 10 meters off, and slightly forward from where it should be as well. It was really strange how far off it was. There's trees in the middle of a football pitch there. God damn it. But I think my top priorities now are to find an overlay source that fills in the gaps that are being left here by my W2XP stuff, and then I'm pretty much golden, pretty much ready to go. Anyway, I'm waffling now. I hope this tutorial was useful to you, and that the two videos combined increased your knowledge and have helped you to create this kind of thing yourself. I was sitting here for 6 days when I first started doing this, just cramming, constantly just trying to do tiles, and I know that isn't for everybody, So I thought, I'll make these videos and you guys can learn and you can have your own sexy looking sim. I mean, again, like, we're not far off the ground and there's like a decent amount of detail on the ground. I mean, it's not like super crisp or anything like that, but it is good looking. It's very good looking. And I might turn up my traffic sometime, actually. Although when I get into like London and Edinburgh, that's probably not a good idea. But yeah, it looks really good, and like the masking on the coastline really kind of sets it apart from a number of other scenery creating tools out there. It's a really good feature. I really like that. And it's just nice to have real world scenery that's that matches the real world, you know. Like we get into simulators because we want to experience something that we might not necessarily get the opportunity to in real life, but does exist in real life, you know. And it's nice to be able to partake in an environment that we also know that exists, rather than just carry out the activity. But as I said, I hope this video has been useful to you. And if you are planning on doing this, you know, scenery creation, I wish you the best of luck in creating your own little set, building your own sim. If there is any tips or hints or anything like that that you have for me that I may be getting wrong or could do better, feel free to let me know in the comments or something below, and I'll certainly try them out because I'm still new to this myself. So guys, for this video, that's it from me. If you find it at all enjoyable, helpful, or useful in any way, feel free to like it. And if you want to see more from me in the future, feel free to hit the subscribe button so that YouTube can spam you every single time I post a video. I hope you guys enjoy the rest of your days, and I will be back here again very, very soon. Thank you for watching, and goodbye.
Ooh.